enzymatic and non-enzymatic responses of Kachalymon against drought stress. Actually, this is part of my PhD research program. I'm doing different types of abiotic stress in this particular Sutra species, Kachalymon. But for this seminar, I'm going to bring up only one type of abiotic stress, that is under drought stress. Coming to the introduction, Kachalymon scientific name is Citrus zambiri, and it belongs to the family Rutaceae. And the chromosome number is 18, and it got the GI tag of Manipur in 2014. And edible portion is pulp, and the type of fruit is Hesperidium, and the mode of propagation is vertical grafting. Kachalymon is a very unique citrus species found in a village called Kachai village, Lukro district of Manipur. Its uniqueness is that the content of ascorbic acid is very high, that is 51%, which is 30% more than other remaining lemon varieties or citrus species. And this uniqueness is now compromised due to change in climate variability. So I'm going to do these present investigations by inducing the artificial drought stress by using a chemicals polyethylene glycol 6000 with different concentration level. The objectives of my study is, after inducing this drought stress, what are the responses, what are the adaptive responses which is undergoing in the Kachalymon seedlings. So coming to the detailed side of the work, I performed this study in the controlled conditions in the lab, and I collected these fruits from the particular village, Kachai village. I start my work with washing of sand. I prefer this sand media because if we planted these Kachalymon seedlings in the soil, there may arise other type of inorganic stress present in the soil. So I use sand after washing. There is a method called sand bath method for this. So for washing the sand, first step is to wash the sand with a normal water. Then again, I use basic solution by using sodium hydroxide 1 normality for one night, and then washing, then bring back to neutral pH 7, and again washing with hydrochloric acid. Like that, I wash the sand, and after bringing it to pH neutral, I dry it for 3 days in the oven, and it is ready for planting. This is the polybags which I prepare for planting the seedlings. The planting material, I first extracted the seeds, and the seeds were washed or soaked in the Babistin 0.5%, so that there will not arise of this damping off and all, which is nursery kind of diseases. For germination of Kachalymon, I did in this one hydroponic types of method. I designed by using a blotting paper holding by a wooden frame, and in the tray I put a nutrient media called Hoagland nutrient media. Hoagland nutrient media is nothing but it is a solution made of measure and different minor nutrients. So then after it reaches the transplantable stage, I transplanted in the prepared same media which I washed before. Then I water until it gets properly established, nearly about 1 month, with a Hoagland nutrient solution. Then after complete establishment, I started the treatment by supplementing that Hoagland nutrient solution with different concentrations level of polyethylene glycol, and I observed this analysis at different days, that is different time intervals in 15, 30, and 45 days. And these are the biochemical parameters which I'm going to talk about. And this on the right side, these are the reference which I followed during this analysis. This photograph is showing the effect of drought stress on the Kachalymon seedlings, that in 15 days their shoot length and root length decreases comparing to the control. The leftmost is the control, which is tall one, and it keeps on reducing with increasing the stress levels. This is also another photograph supplementing to the before one. There's also effect of drought stress on shoot and root length after 15 days, 30 days, and 45 days. In this graph, pigment are also very important parameters to be analyzed when the plants are undergoing drought stress to check the impact of drought stress on the seedlings. So in all 15, 30, and 45 days, but in all chlorophyll pigments, that is chlorophyll A, chlorophyll B, and total chlorophyll, it is found decreasing with increasing stress levels. This may be due to the activation of stress hormone called AVA, which leads to increasing of chlorophyllase enzyme, which leads to degradations of chlorophyll pigments. And even in carotenoids, it is found decreasing with increasing the stress levels in it. And even after 45 days, it keeps on decreasing. This shows the impact of drought stress on Kachalymon seedlings. coming to the next parameters, that is reactive oxygen species. Reactive oxygen species is a very harmful species when plants are under stress conditions. Because of this reactive oxygen species leads to cell death of the plants. So there are three types of reactive oxygen species, that is superoxide anion, hydrogen peroxide, and hydroxyl radical. The first A and B graph is showing the superoxide anion, that superoxide anion keeps on increasing with increasing the stress levels in all 15, 30, and 45 days. And even in hydrogen peroxide also, it keeps on increasing in 15, 30, and 45 days, but in 45 days it is boundless, showing the adaptive response of acyl element. And lastly, this hydroxyl radical also, it is found increasing with increasing the stress levels. But in shoots, is the 45 days, the increasing rate is decreasing in hydroxyl radical in shoots comparing to roots. This may be due to the root organ is directly in contact with the soil under stress conditions. Enzymatic antioxidant activities. Those reactive oxygen species which increase the productions during stress conditions will be controlled by this plant's defense mechanisms, that is enzymatic antioxidant activities. First of all, catalase is very important parameter which detoxify the free radicals which is produced. So this catalase increases with increase in stress levels in 15, 30, and 45 days. Similarly, in roots also it increases in all 15, 30, and 45 days. Means that acyl element can fight, or the acyl element can detoxify the free radicals, which increase that one to less harmful radicals, that is hydrogen peroxide. And lastly, this hydroxyl radical, this ascorbic peroxidase, it is very necessary enzyme which helps in the production of ascorbic acid. The last two enzymatic antioxidants, that is peroxidase and glutathione reductase, this also help in detoxifying all the free reactive oxygen species. There are again two important non-enzymatic antioxidants, that is ascorbic acid and tocopherol, that is vitamin E, which is responsible for detoxifying of all the free radicals which is produced when the plants are under stress conditions. So in the graph, it is shown the same pattern like that. That is, it increases with increase in the stress levels in all 15, 30, and 45 days, with maximum production in 45 days in both shoots and roots. So, in the conclusion, I can say that from my research work, that even though when the acyl element is under stress conditions, the mechanism, that is enzymatic and non-enzymatic antioxidants mechanisms undergoing inside the plants can protect themselves by these defense mechanisms. The first one, I'm writing on impact on pigment content. Drought stress leads to consistent decline in chlorophyll and carotenoid content in acyl element. And carotenoid content also shows immediate reduction when it is exposed to stress levels, with fluctuations over time that may be due because of dynamic adaptive responses. And talking about the ROS production, superoxide anion increased significantly in both shoots and roots under stress, with higher levels observed at higher stress levels. And even the hydrogen peroxide also follows the same pattern with consistent increase over time. Hydroxyl radical production also increased initially, particularly in shoots compared to roots. Enzymatic antioxidants also, all those catalysts, superoxide dismutase, ascorbic peroxidase, glutathione reductase play an important role, that it shows increases pattern in the graph, which shows like it could defend or it could detoxify all the reactive oxygen species produced. And both non-enzymatic antioxidants, sorry sir, coming to the conclusion, I can say that from my research work, the major stress mitigating mechanism in acyl element involves enzymatic and non-enzymatic defense mechanism, with enzymatic defense mechanism playing the role. So for future, I can go for this molecular work by knowing the target genes which responds in stress conditions, and go for plant resilience citrus crops. Thank you.